Hey everybody, my name is Todd Rothman and welcome back to Organic Chemistry 2. In this video we're going to go over the nomenclature of aldehydes and ketones. Now I want to point out, it's very important, we're not going to look at class 1, we're only going to focus in on we're not going to look at class 2, we're only going to focus in on class 1 for the rest of this chapter. Okay, so for all sections, there are a few points where class 2 molecules come up, but not very frequently at all. Most of our focus is on class 1, which is aldehydes and ketones. Okay? So nomenclature here is pretty straightforward. What we want to do is we want to basically identify the trends. You should know nomenclature. There's a lot after you get through the next chapter. Between all the different types of class 2s, you're going to see there's a lot of nomenclature. But for now, it's pretty straightforward. Let's start by just first off, going over a priority list. And this is something that tends to be helpful as you continue to learn more names. So the priority trend is like this. And what I mean is who's going to be the parent, right? So who's the parent? And if it's not a parent, then what's its name as a substituent? That's what I want to point out. So parent and then substituent name. Now, the most important parent that you can have, the one that wins all the time, is a carboxylic acid. So carboxylic acid is at the very top of our list. Now, aldehydes and ketones follow, right? So aldehyde and ketone, they're next up, and this is the order. Aldehyde's higher priority than ketone. So this is increasing in priority going this way. All right, now from here, then you have alcohol types. So we were going to have the thiol, which is actually a sulfur with an H, rather than a regular alcohol, which is next up. Alcohols are higher priority than amines. Amines are higher priority than things like nitriles. Okay? And so then that would be the next one up. And then after this, then we get into our alkynes and alkenes. So it's actually, if we want to continue, it would be where we have the hydrocarbons down below. Hydrocarbons. Right? And that would be the alkynes, the alkenes, the aromatic systems, and so on. Anything that's carbon with H on it. So, as you can see at the very top, that is the highest priority. So, if you have a carboxylic acid, and no matter what else is on this, whether it's a nitrogen, an oxygen, some carbonyl, anything, doesn't matter, this is the parent, the carboxylic acid, because it's the highest priority. Okay? So, this is the trend. Now, as far as the naming, well, this has no substituent. I guess you can call it a carboxy group if you had to. So maybe I'll change that. Well, it's carboxy would be the name of this as a substituent. But really, I mean, the only time you would ever have a carboxy is if there's a lot more complexity and it's easy to name it as a substituent. But normally it's the highest priority. Now, for aldehyde and for also ketone, now remember, this is if they're not the parent. If they're the parent, well, you're going to learn in nomenclature now. But if they're a substituent, if they're a branch, then these two are called oxo groups. Oxo. So you can have an oxo as a carbonyl, C double bond O, and it's independent of whether it's a ketone or an aldehyde, it's the same thing. So for example, let me give you an example of what this would look like. If I have a carboxylic acid, and over here's a double bond O, we could say we have a 1, 2, 3, 4. Notice how 1 is the carboxylic acid, right? So this is a 3-oxo, and then it's 4 carbons, so butane, and then the name of a carboxylic acid is oic acid. So 3-oxo butanoic acid. You don't have to worry about the nomenclature of a carboxylic acid yet, but I want to give you an example. So here's an oxo group. This is a 3-oxo because the parent is the carboxylic acid, carbon, right? So that's what I mean by that. And notice it happens to be a ketone. Well, if the double bond O was on number 4, it would still be an oxo, but now it would be an aldehyde, right? And you'll figure that out based on the position of the carbonyl. You don't need to change the name for that. Okay, so the next one up, the thiol. Now, a thiol is the name. So thiol is the actual name. This is a SH, right? A SH is when you have a thiol. OH is an alcohol. We call them hydroxy, right? Hydroxy groups or hydroxyl groups. Amines are amino groups, like amino acids, right? So carboxylic acid is the parent acid, but it's got a branch, a branch. So nitrogen, this is like NH2 or NH3 or NH2R or NHR2 and so on. So just a nitrogen is an amino group. Nitrile CN, right? So this is called the cyano group as a substituent. So we could have a cyano carboxylic acid, right? Like 3-cyano butanoic acid or something, right? So that's a cyano group. And then hydrocarbons, of course, you have alkenes, alkanes, alkynes, and all the stuff that goes with those names, and aromatic like benzenes. Okay, so here is your priority. So the first thing is parent priority, and now we've got that down. This is your little list that you should know. I'm not sure how important or how detailed they're going to get with this list with you, but at least now you know the list, okay? And you get the general trend of things. Now, the one thing that's not on this list is that there's a whole bunch of carboxylic acid derivatives, and we're going to have a whole chapter on that. And so when we learn the chapter, we'll see how we could break this one up right here into a whole bunch of different derivatives like acyl chloride, acid anhydride, amide, ester, and we'll figure out their priority then. Okay? But for now, that's good. All right. Now, the next thing I want to talk about, that's number one. Number two, let's talk about aldehydes, and then we'll talk about ketones. So aldehyde nomenclature. So now we know where it falls in the pecking order. It's pretty much towards the top. It's right below carboxylic acid. And so pretty much everything falls as a substituent to it. Now, the way that we name an aldehyde is the generic name for it is an alkane. If it's an ane, it could be an alkene or alkyne. But if it's an alkane, we add, instead of an E, an AL for aldehyde, alkanal. So butanal, right? So we might have something like this, and we call this right here, in this case, a pentane al. Now, one thing that's interesting about this is that, by the way, notice how I didn't number 1 or 5, because we know it's number 1, right? The parent always has the highest priority. So the C double bond O is the highest priority other than carboxylic acid, which is above it, right? So we know it has to be number 1. Now, even if there's, let's say, some change to this functionality, like let's say I have a double bond here, and I have a double bond O here, and now there's some complexity, right? So we might say, well, if we number this 1, it's going to be 3 and then 4. But if this is 1, then it's 1, 2, 3, 4, 5. 3 and 5. So is it better to number left to right? The answer is no, because the aldehyde, ketone, and alkene, aldehyde is at the highest priority in our list. It's above everybody. So we have to number it 1. So in this case, we have 1, 2, 3, 4, 5. So how would we name this? Well, first we go, of course, with substituent. And so we have on carbon 3, we have an oxo, 3-oxo, right? Remember oxo, carbonyl? Okay, now 4 is an alkene, so we're going to say 4-pent. Instead of ane, like we did above, ane, it's now en. Whoops, pentan. So we have a TEN, and now al is next. Now, the thing is that we don't have to say 1-al because we know it's 1-al. So we write pentene-al. And we're done. So we could say 3-oxo 4-pentenal, or we could say 3-oxo pent 4-en-al. And they mean the same thing, right? They're both fine. I usually put the number 4 next to the parent name if it's not, if there's no other number that we need. But if there's more than one number, you could put it right next to each other, the functional group. All right, so here you have it. So that's our nomenclature. Nothing really new compared to what we did all last semester, but you should be familiar with how this works. Now, like there's other things that we should know. Like there's some. This is the basic rules, but let's talk about some common nomenclature, because these are very it comes up more now than ever in other chapters that we might have covered up to now. So The first one is called the form group, form. Now, when you have a carbonyl and it has an H, that's called a form. So it could be formaldehyde if it